All right, so this is a final exam given back in fall of 2021. And so it's just an idea, just like to help you get an idea of what the final exams have looked like, and also on the extra credit practice finals that are in that final exam module. Remember, you can get those done. And I would highly suggest you do those after you kind of do all your studying and stuff, just to see where you're at in, being able to get all this stuff done, and that you can work those problems without any notes. Just give yourself about an hour and a half and then use your calculator. Those are a little bit shorter exams. Those are the ones that we actually gave during the pandemic, and so they were online, and so anyway, they were just a little bit shorter than what we normally do. So you'll have 2 hours to do the exam. There's 25 questions, and you can use a scientific calculator, right? And so that's the only thing that you're going to be able to use. So any formulas and stuff you need to know, you got to make sure that you have those all memorized. Okay, but keep in mind that there's a lot of helps for you in that final exam module. So keep looking back to those to get some extra help on things that you want to work on there. Okay. All right, let's go ahead and get started on this. So this first one says, find the equation of a line containing the point -6, -3 and parallel to the line 2x plus 3y equals 8. All right, so with this one, all right, we're going to need to use some of the things over here with under the lines. All right, now we're not given 2 points, and so you don't need to, use the slope formula on this. However, if you look at the point slope formula, we do need to know what the slope is. Okay, so let's see. Okay, so when we're doing this, we want to use that slope formula, which is, or I should say point slope formula, point slope equation, which is y minus y1 equals m times x minus x1. All right, and so things that they're giving us here, well, that point is our x1, y1, but we need to know what the slope is. We're not given the slope. However, we're given this equation that it's supposed to be parallel to. So what do we know about parallel slopes? Parallel lines, sorry. Oh, parallel lines. All right, they have the same slope. So we need to figure out what the slope of this line is. And we can't see what it is until we get it into that y equals mx plus b form. So that's what we want to do. So we're going to take this and get y by itself. So I'm going to start off by subtracting the 2x over. Oh my goodness, it keeps skipping. Okay, and so that's going to give me 3y equals -2x plus 8. And then I need to divide by 3. And so y equals -2/3 x plus 8/3. So once I have it in this form, then that number in front of the x is my slope. Right, so I can't use, like 2 is not my slope up there because it's not in that y equals mx plus b form. Because remember that form, y equals mx plus b, m is the slope and b is the y-intercept. Okay, so we found the slope. And so let's go ahead and we're going to put these things in here now. So I've got y minus my y1, which is -3, equals m, and I just found my m to be -2/3, times, so parenthesis here, x minus a -6. Now be really careful with these. When you're minusing a negative, it's easy to, forget to do that. So really this is saying y plus 3 And this is really x plus 6, right, when we're minusing a negative. Okay, so next line I have here, so y plus 3. And then here I need to distribute that negative 2/3 through. So I get negative 2/3 x. And then I need to do negative 2/3 times 6. Now you can just do a little, side work over here if that's, hard for you to do in your head. And so we're just multiplying across the top. We get negative 3, multiply across the bottom, or sorry, negative 12 on the top, 3 on the bottom. And so that reduces to be negative 4. And then we just need to subtract that 3 over. So then we end up with y equals negative 2/3 x minus 7. And that is going to be the answer for this. So I found a line that goes through that point and is parallel to this other line. And remember, I can tell those lines are parallel to each other because their slopes are the same. Okay. All right, questions on that? And make sure you're speaking up. Sometimes I don't see things in the chat. So if you're able to unmute and just talk, that will be the easiest way to get my attention for sure. Okay. All right, the next part, we are going to be dealing with some imaginary numbers, these complex numbers. So on this first one, it wants us to subtract those. And on the second one, it wants us to multiply them. So watch really closely on the final, because sometimes it's just easy to, just to overlook what operation they're having you do here. So when we're subtracting these, first thing that we want to do is distribute that negative through to both signs here, right? Or to both numbers, I mean. So we're going to give both of those a negative. So when I do that, I have negative 2 minus 4i. And when I distribute there, I get negative 3, and I'm going to write it underneath here. And then plus a 3i, right? I'm just distributing that negative through because I'm subtracting all of that. And then I just need to combine these together. So I get negative 5 and then minus 1i, or just I. Okay? And that would be your answer for that one. Now on this one, we need to FOIL these out, right, because they're being multiplied together. So let's do our first. So negative 2 times 3 is negative 6. Negative 2 times negative 3i is positive 6i. Then I'll do our inside terms, which is negative 12i. And then a negative times a negative is a positive, so positive 12i squared. Okay, so what do we need to do with that I squared?
Doesn't I squared equal -1?
Yeah, it does. So over here under imaginary numbers, down at the bottom there, you can see I squared equals -1. So whenever you have an I squared, we got to change that to -1. All right, so what I'm going to do here is I'm going to just kind of do a shortcut way of doing it. So I get rid of that I squared and I change it to a negative, because they're kind of doing 12 times -1, which is -12 is what I need there. Okay, and then I just need to combine my like terms together. So -6 minus 12 is -18. And then my i's combined together there, 6i minus 12i is -6i. And then that would be my answer. Okay, make sure you're speaking up if you have any questions. If you have a question, somebody else probably has that same question. Okay. All right, let's look at this next one. Solve the absolute value equation. Okay, so when we're dealing with absolute values, remember that there's two ways that we can come up with an answer. So by that I mean, if I said, what's the absolute value of -3? Well, -3 is three places away from 0 on the number line, so that's why it's 3. But also if I said, what's the absolute value of 3? The answer to that is also 3. So there's two ways to get the same answer. All right, so when we're doing this, you've got to remember with absolute value equations, you've got to write two statements, and that's usually what people forget to do on this one, especially since it's been so long since we've talked about these absolute value equations. Okay, but first we've got to get the absolute value part by itself. Okay, so I'm just going to also put on here, isolate absolute value. Okay, so to get it by itself, let's see, I'm going to start by adding the 4 over. So that's going to give me 3 times the absolute value of x plus 5, and then 8 plus 4 is 12. And now the absolute value part is still not by itself. I need to divide both sides by 3. So that's going to give me absolute value of x plus 5 equals 4. Okay, so now I have it by itself. So now I can write my two equations. So I'm going to do that over here. So it starts off as absolute value of x plus 5 equals 4. But my two equations that I'm going to write, the first one's going to be exactly like it is without the absolute value. So x plus 5 equals 4. And then the other one, the stuff inside there is going to stay the same, x plus 5, but then we're going to change the sign to negative 4. Now, you could change the, both signs of the left side of this if you want to, and leave the right side alone. I just think it's easiest just to change one sign, so that's why I just changed that one over there. But you'll get the same answer either way, as long as you remember to change both of those, right? Change x and 5 to their opposites. Okay, and then we'll just solve these. These are now just linear equations to solve. So we get x equals negative 1. And then here we get x equals negative 9. Okay? And then those would be my answers. And remember, with any time it tells you to solve something, you can always check it, right? So put those numbers back into the original equation, simplify it, see if you come out with a true statement. So I highly recommend you do that on the final, especially if you have, some time left over at the end, just to, double check those answers. It's a good way to use that. Use some time. Okay. All right, next one. So in this one, we're trying to simplify these radicals. We've got these square roots. And so this one was on the last exam, and I'll just say a lot of people miss this on the last exam. So you might want to star this one and stuff if you maybe were kind of confused on how to do it, because you need to first start by simplifying all of the radicals first, because we can only add and subtract radicals together if they're like radicals. Okay, so I'm going to just say, start by simplifying radicals. All right, and so to do that, you might need to go and, do these prime factorizations. So depending on how you, learn to do it, how you like to try and simplify, there's more than one way to do this. But the way I like to do it is to just break these down into their prime factorization. So I know 6 times 8 is 48, but then 6 is not prime. It breaks down to 2 times 3, and 8 is 2 times 4, and then 4 is not prime. It breaks down to 2 times 2. Excuse me. Okay, so we end up here. Let's see if I can make it all here. So I'm going to just try and write this out here. So I've got 2 times 2 times 2 times 2. Right, you see I have 4 2's there. And then times 3. Okay, and then minus, I've got that 5x on the outside. And then my 40 on the inside, 40 breaks down to be 4 times 10. And then that's 2 times 2 and 2 times 5. All right, so I've got 2 times 2 times 2 times 5. And then I still have an x in there, so don't forget about your x. Some of you guys were forgetting about your variables on there. And then the last one here, I'm going to run out of room here, it looks like. So I might just erase this 48 here so it's not running into it. Okay, so then I've got 90 now that I need to break down. I'll do that over here. So 90 is 9 times 10. 9 is 3 times 3, and 10 is 2 times 5. So I've got 4, and then inside the square root, I've got 3 times 3 times 2 times 5. All right, so remember they're all square roots. So with square roots, there's like an invisible 2 that's here, right? That's the index. And that's telling you how many of the same number you need in order for that to come out. So meaning I've got a pair of 2's here, so that can come out as a 2. I've got another pair of 2's, so that can come out as a 2. So you're trying to take out as many as you can. Okay, but 3 is still stuck inside there. So what do I have left here? Well, 2 times 2 is 4, and then square root of 3. All right, is what's left inside there. Okay, how about this next one? Well, I've got a 2 that can come out, and when that 2 comes out, it wants to be multiplied by what's out there already. So I'm really having to do negative 5 times 2. That looks really weird. That's supposed to be an arrow. Okay, 2 gets to come out, and so that's negative 10. And I have an x there already, so I need to make sure that I keep that there. And then left inside is 2 times 5 times x, so that would be 10x. Okay. All right, and then on this next one, it looks like a 3 gets to come out. And again, when it comes out, it's going to multiply by that 4 that's already out there. So I'll have 3 times 4, and then square root of 10 there. Oops, I forgot my x's over here, didn't I? I should have had an x times an x times an x. So an x gets to come out, and an x is still stuck inside. So that means there I've got plus 12x square root of 10x. And now I just need to combine the like terms together. Well, the only ones that are like terms are these last two terms because they're both square root of 10x. And so you're just combining the stuff that's on the outside together. Okay, so for our answer on this, we keep that 4 square root of 3, and then negative 10x plus 12x is going to be 2x. And then we still have that 10x inside. So all of that will be your answer. Okay, what questions do you have on that one? Because like I said, I know that there was quite a few people on the exam, on this last exam, that missed it. So if you're confused by anything, let me know, because I'm sure you're not alone. Do you understand where those numbers came from, where the variables came from? Okay, I'm counting on you to speak up if you have questions. All right, so this last one is log. You haven't been tested on log since that was in the very last chapter, right? The very last module there. So when we're dealing with logs, and one of the things that I'll say is if you're ever dealing with anything that's in log form, like, and you're just feeling stuck and you're like, I don't know what to do with it, try and change it to exponential form, and usually it's gonna, you're gonna see that it'll be a little bit easier to solve. So remember down here, this logarithms, the bottom there, right? This is showing log form to exponential form. So you've got to make sure you know how to do that. So when we're doing this, we're going to take that base, the 3, and we're going to raise it to the 4th power. Okay, so I've got 3 to the 4th power, And then that's going to equal all of the stuff that's there in the parentheses. So equals 7x plus 11. Well, 3 to the 4th power, right, is 3 times 3 times 3 times 3, which is 81. And then we're just going to solve it, just like we've done a lot of times before. Subtract that 11 over first, and then divide by 7. So x equals 10 on that one. Okay, and again, I mean, you could put that 10, back in here. It might be harder to put it back into the original equation, but once you've changed it to exponent form, you could put it back in there and make sure that it checks out. Okay. Okay, so that was something from the last one. Remember, the only time you're going to be tested on anything from that last module is here in the final exam, so you will see a few things there. Okay, so this one is the circles, right? And so in order to take a circle that's in general form and change it to standard form, we've got to do completing the square. And I'd say on the last exam, it was probably about half and half. There was quite a few people that remembered how to do it, and some I could tell that they were like, oh, I can remember part of it, but I can't remember exactly what I need to do here. Okay, so let's look at this together. So first thing you want to do is whatever that constant term is, you want to move that over to the other side first. So we're going to move that -5 over to the other side. And then I'm going to rewrite this in a certain way. All right, so I'm going to put my x's in green just so they stand out here. So I'm going to have x squared plus 8x. So I'm going to put these together. And then plus blank. So this is what I'm trying to figure out, is what goes inside that blank. All right, now let's get our y's together. So I've got plus y squared plus 10y plus blank. And then that's going to equal that -5 plus whatever we have in the green blank and whatever we have in that orange blank. Okay, so plus blankety blank. All right, so how do we figure out what goes inside those blanks? Who can remind us? How do we figure that out?
Do we divide the middle term by 2 and then square it?
Yeah. All right, so we'll take 8 divided by 2 is 4, and then 4 squared is 16. All right, so 16 is what's going to go in that blank. And then over here, same kind of thing. We're going to take that 10, divide it by 2, that gives us 5, and then take that 5 and square it, which gives us 25. Okay, and so since I added 25 here, I've got to add 25 to the other side. I added 16 to the left side, so I've got to add 16 to the right side. Okay, and now these we're going to just be writing in, like this is called a perfect square trinomial. And so that can factor to be x plus 4 times x plus 4, because we're thinking what multiplies to be 16 that adds to be 8. Well, since it's the same thing, then we write it as x plus 4 all squared. All right, and then similarly, we'll do that with this one. All right, so now we have y plus 5 all squared, and then that's going to equal what we have here together, which is going to be, is that going to give us 30? Let's see, 20 plus 16 is going to give us that 36. Whoops, I'm writing it in the wrong place there. Okay, so that is the equation. So that's our first answer for part A. Now it wants us to tell us what the center of the circle is. So how do I write the center of that circle? Who can remind us of that?
Wouldn't it be your h and k, so just 4 and 5? 4 is your x.
close, it's going to be the opposite of them, but you're right, it is those numbers, right? So one thing that I say is like insiders or liars. So if you have something inside parentheses like this, you're always going to be like doing the opposite of what it is. And so this one's going to be -4 and -5 is where our center is. Okay. But yeah, you're right. We're going to be using those there. Okay, how do we find the radius?
Is it the square root of 36?
Yeah, so whatever that number is there, take the square root of it, and that will give us our radius. Okay, awesome. So yeah, make sure you know how to complete the square. All right, there is always, 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 I can't even remember a final exam when there hasn't been a question like this on it. If you go through some of those other practice finals, you'll see like these probably show up every single time. Okay, so super important one to make sure you know how to complete that square. Because those of you going on to 1050 next, you definitely need to make sure you know how to do completing the square, because you're going to be using it in other ways, and they're going to actually expand on what you need to do with completing the square. Okay. Okay, so the next one, use long or synthetic division to divide the polynomials. Well, on this one, and I'll just tell you, on the exam, if they have this question on there, you will be able to do it by synthetic. And so remember, the way that you can tell if you can use synthetic or not is the coefficient on this term is a 1 and the exponent's a 1. So say if this said 2x plus 3, if that's what it was being divided by, then we'd have to do long division. But because our coefficient is 1, our exponent is 1, we can do synthetic. Okay? And they're always going to give it that way. And so I'm going to choose to do this by synthetic just because it's a little bit easier. Okay, so just like I was saying before, like insiders or liars, right? So we're going to take, and we need to do the opposite of what that is. So we're not going to put a 3 there. We're going to put a -3 inside that. And then we're going to write the coefficients down. But notice, you got to take really close notice of something. Do you see that the x squared term is missing? And so we got to have a 0 to hold that place for it. Okay, hint, hint, hint. That is usually something that always happens. And it could be more than one place value is missing. So you'd have to put more than 1 0 in there. Okay, but this one is just missing that one. So I've got to have 2 is a coefficient there. Then my next coefficient would be 0 because I'm missing that x squared term. Then -10 and then +14. And then I'm going to skip a space, right? So I have room up above and below this line here. So very first thing that we always do with synthetic is we just bring that first number straight down. Okay? Then we take what is ever in the answer row and multiply it by the number that's out there. So 2 times -3 is -6. Okay, then combine those together just the way they are. So that's going to give us -6. Then start it again. -6 times -3 is +18. Combine those together, we get a +8. Do it again. 8 times -3 is -24. Combine those together and we get a -10. All right, so this very last number right here is the remainder. Okay, it's always the remainder. And again, in 1050 and in those of you going into 1090 or 1080 is just like a faster way to get through 1050 and 1060. They combine it one semester. So anyway, so any of those classes that you're going on to next will definitely be using a lot of this synthetic division, not so much the long division. So that's why I want to make sure you know how to do this coming out of this class. Okay, so but now we're not quite done. Whoops, I keep accidentally moving that. So we're not quite done. Now we need to write it in polynomial form. And so it started off with my highest exponent was a 3. So I need to go 1 down from that when I write my answer down. So this is going to be 2 x squared, right? So instead of a 3, it's 2, and then just keep going down, minus 6x plus 8, and then plus, and it says to write it like this, so the quotient with the remainder over the divisor, so I need negative 10 over what I'm dividing by, that x plus 3. So all of that together is my answer.
Could the remainder be rewritten or I'm sorry, the plus sign prior to the remainder be rewritten as a minus since the remainder is negative?
Yep, either way I would accept is right.
Okay.
So you could write this as minus 10 over x plus 3 or plus a negative 10. Either way is totally fine. Either way is perfectly acceptable. All right. Still no questions? I feel like some of you guys are just being silent. I appreciate you asking that last question. Okay. Okay, so this next one, all right, we're going to be using those properties of exponents, and some of these have, notice, some fractional exponents in it too. And so our fractional exponents, we have to just treat, I mean, we're doing the same thing with them. So if you look over here, remember, so, I mean, it says, you know, you got to know your properties of exponents and make sure you know how to work with fractional exponents. So that's usually something that shows up on the exam for the final. Okay, so there's a couple of different ways that we could do this. And so I'm going to show you the way that I would go through it, but that doesn't mean it's the only way you could do it. Okay, especially with these properties of exponent ones, there's a lot of different orders you could do this in. Okay, but for me, I don't like having negative exponents. I know in the end, I can't have any negative exponents left in my answer. And so that's what I usually try and work on getting rid of. And so I usually will start, if this outside one is negative, I usually start and try and change that to a positive. And in order to do that, I need to flip this fraction. All right, so everything on the bottom, just how it is written there, is going to flip to the top, and everything on the top is going to flip to the bottom. So be really careful with this, because sometimes people try and change a few things here. So just like this is written, so on the top I'm going to have 5x to the negative 1/4 power. Okay, I haven't dealt with this negative exponent yet. I'm just dealing with this guy out here. Okay, so keep that negative if you're flipping this. And then y to the negative 2 power. And then over, well, the top is going to go to the bottom, which is 6x to the negative 3/2. And then y to the 5th. And now it's being raised not to the negative 2 power, but to the positive 2 power, right? I flipped those so I can change that to a positive. Okay, now the next thing I like to do, again, I don't like having negative exponents in there. So now I'm going to flip those to where they're going to be happy, right? So if it's a negative exponent, like this x to the negative 1/4, it's unhappy upstairs. So I'm going to flip it down to the basement. All right, but notice y to the 5th is positive, perfectly happy where it's at. So leave it where it's at, right? Don't be messing with that. Okay, so when I write this out again, so my 5 and my 6 stay where they are. X to the 1/4 comes downstairs. X to the negative 3/2 is going to become positive 3/2 when I flip it upstairs. And then I've got y to the 5th is happy down there, but y to the 2nd wants to move down there to be happy. Okay, and then again, still, I haven't raised it to that 2nd power yet. Okay, so be careful with that. All right, next thing I like to do is try and get my my variables together. So I want to get that together, and then I want to get this together. Okay, so when I do this, let's see. So I still have 5 on the top and 6 on the bottom. But this x to the 3/2 and x to the 1/4, remember when they're connected by division, I need to subtract those. All right, so I'm really trying to figure out what is 3/2 minus 1/4. Well, I need to get a common denominator in order to do that. So I need common denominators 4, so I'm going to times that by 4, or 2 on the top and bottom. So 6/4 minus 1/4, whoops, which gives me 5/4. Okay, and so that means, and so I subtracted those, and whatever I'm left with, that stays on the top. It's always the top minus the bottom, and the answer's on the top. So this would be x to the 5/4 on the top. Okay, and now my y's, y to the 5th, y squared is going to give me y to the 7th. That's downstairs. All right, make this a little bit shorter there. Okay, and then I still haven't squared everything, so that's the last thing I need to do. And make sure you remember to give everybody, right? You're going to square everything, right? So it's easy to forget that these numbers out in front need to be squared also. So 5 times 5 is 25. And then on the bottom, I have 6 times 6 is 36. Okay, and then again, I'm going to do a little bit of, side workout here just to make sure. So when I have a power raised to a power, I'm multiplying those. So I'm going to take 5/4, and now I need to multiply those together. So I'm going to multiply it by 2/1, right? Which is going to give me 10/4. So I get x to the 10/4, but 10/4 actually will reduce to be 5/2. So we want to keep it in reduced form. Okay, and even here, like usually I don't multiply across. I usually will reduce like this first, and then I can see, all right, 5 times 1 is 5, and then 2 times 1 is 2. So, okay, make sure you have that simplified. So x to the 5/2 power, and then y to the 7 times 2 power, so y to the 14th power. And then everything is done. I've got my numbers. There's nothing I can't simplify that fraction anymore, but if I could, I'd want to. My x's are together, my y's are together. I have no parentheses left in my answer. I have no negative exponents left there, so it is done. So those are kind of the things that you're looking for on that. Okay, and like I said, there's more than one right way to get there. So I don't want you to think like, oh, if I'm not doing it the way that Becky is doing it, then I'm doing it wrong. Because on this question, that's probably not the case. So many different ways to work these. Okay, I know that some people like to start off by distributing that, power of -2 through to everybody first. And that's fine to do. It's just like sometimes people tend to make mistakes when they're multiplying with negatives. And so that's why I chose not to do it that way, but it's still a good way that can get you there just great, as long as you're careful with your negatives. Okay. All right. Doing so much talking. Is everything making sense for you guys so far? How are you feeling? I want to check in with you.
So only if it's negative you flip it?
Yes, that is correct. Yeah, so one thing that I give like as an example, just a silly example to help people remember it, is like, you kind of think of it like as an upstairs and a basement, right? An upstairs and a basement. And so I just said, yeah, when, in my house, when we finished the basement, right? I had kids that were unhappy upstairs. They were negative, right? They were not very happy upstairs. They wanted to go to the basement, and then they were happy, right? They were more positive when they were down there. Except for my daughter, when she went down there, right? She discovered she doesn't like spiders so much, and spiders hang out there. So she was kind of negative, and so then she had to flip back upstairs, right? So yeah, so sometimes there's like that little flip-flop thing that you got to do there, depending on, where they're negative. So just a silly way to kind of help you remember. So if they're positive, if they're happy, leave them be. Let them stay where they are. Only when they're negative do you want to flip them. Okay, well, let's look at number 9 now. So this one, and this is again in this last module where you're talking about inverse functions, okay? And there's 4 steps to finding the inverse function, and so I'll probably just write those over here as we're going through it, because I think it makes it kind of easy to see. So the very first thing that you want to do when you're doing that is you're going to change f of x to y. Okay, so I'm just going to replace that. F of x is the same thing as y. We write it as f of x just to say this is a function, just to make it stand out. I am a function. Okay, but in order to do this, it's going to be easiest to have it not written in function form. So I'm going to have it y equals 9x minus 5. Okay, then after I do that, because finding the inverse, really what you're doing is you're switching the x's and y's. So that's what you're going to literally do here, is where the y is, you're going to put an x, and where the x is, you're going to put a y. So I'm going to change this to be x equals 9y minus 5. And then the third step is we want to solve for y. So to get y by itself here, I'm going to start by adding 5 over. So I get x plus 5 equals 9y. Sorry about that. And then I need to divide both sides by 9 to get y by itself. Okay, and then the last thing I need to do is I need to have it written in this inverse notation, so that f to the negative 1 power of x is telling us it's the inverse. So now we're going to change y to that. Read this as the inverse of f of x, but f to the negative 1 power of x. All right, so when I write this down, I've got f to the negative 1 power of x, or the inverse of f of x, equals x plus 5 all over 9. And then that is your answer. That is the inverse. Okay, and so it's just those 4 steps you have to take to find the inverse. Okay, now, right, got like all these F words in math that people just don't like, right? Functions, factoring, fractions, right? So we've dealt with some fractions, we've dealt with some functions. Now we got to look at some factoring, right, on this. And so factoring is such an important skill to have. Like, that's one of the most important things. If you get nothing out of this class, you've got to make sure that you can come out of this really knowing how to factor well. Because again, all of the other math classes you're going to take after this, you need that skill. Okay, and this is the type where people seem to struggle the most with being able to factor something like this, because that leading term is not a 1. And that's what kind of throws people off when they're doing that. So I'm going to write it over here as we're going through it, so I have a little bit more space here. But what I want to do is I'm going to take that first term, so this is written in descending order, so I'll take the 12 and the negative 3, and I'm going to multiply those together. So I'm asking myself, what multiplies to be, well, 12 times negative 3 is negative 36. What multiplies to be negative 36 that adds to be that middle term, that negative 5? Okay. And so sometimes you just have to list out just, things in order here, keep it organized. So meaning you can start off with 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't go in, 6 times 6. All right, and then we're already back, like there's no numbers between 6 there, and I've gotten, everything on the other side of it. So that's what I mean by working organized. So I know I have all of my factors here. Now I just need to look at these and see which one, if I add or subtract them, would give me a -5. So what's going to be my winning combination on this? Which of those factors?
-9 and 4.
Yeah, -9 and +4 is what we want. All right. And so then you're going to use that. There's a couple of different ways that you can go from here, but it seems like most people like to rewrite this. So they're going to use this, and instead of having this -5x in the middle, we're going to rewrite this to have 4 terms. Oops. Can you mute yourself? Somebody's talking.
I was just gonna ask a question.
Oh, okay. Yeah.
I feel really silly. How did you get -36?
Yeah, so do you see how they underlined the 12 and the -3? So 12 times -3 gives us that -36. So I'm always looking at that first and the last. That's not a silly question. So
thank you. That's the part that I always forget when I get to the exam. I'm like, wait, how did we get this number?
Yeah, exactly. And I know you're not alone on that, so I'm so glad you asked. That is great. Okay, so let's look at the next one here, or the next part. So I'm going to rewrite this as a 4-term polynomial now, so that 12x squared stays the same, but instead of -5x, we're changing that to be plus 4x and then minus 9x, right? That 4 and -9 that we found there. And then that -3 still comes down as part of it. So now we've changed this into a 4-term polynomial. And so when we have those, the best way to factor those is factor by grouping. So you want to look and see, okay, what is the greatest common factor that can come out of these first 2 terms? And by the way, like looking for that GCF first is always, always, always a good thing to do. And sometimes I like do it in my head and I forget to say like that I'm doing that, but I looked at the beginning to see, was there something that could divide, like a number that could be divided by the same number here, and there's not. They don't have a common factor, so that's why I went straight to this. Okay, but always, always, always look for that first. Okay, so on this, 4x is the greatest common factor there, so 4x comes out, and then left over, if I divide each of these parts by 4x, that's going to give me 3x, and then 4x divided by 4x is 1. And then on this next one, since this is negative there, that is, we are going to take a -8 out. We're going to, or negative number out there. And so it's going to be -3 is our GCF. -3 divides into both of those. And that's going to leave me with 3x, again, plus 1. All right, and I need these guys to be the same. If you don't get to the same thing right here inside, then you've done something wrong. Okay, these got to be the same, because now that goes in one parenthesis, that 3x plus 1, because it's the greatest common factor of both of those 2 terms. And then left over is that 4x minus 3. And then that is your answer. And you can check by foiling it. All right, so foil that back out, and you better come back with what you started with. So there's definitely a way that you can make sure that you have done it right. Okay, so check by foiling. All right, and so on this other factor problem, we can see, we've got some exponents here and stuff, but it looks to me like there might be a GCF that can come out of this. So let's just look at the number part first. What is the biggest number you can see that could divide into both 48 and into 27? You can use your calculator too. Like I would just go in your calculator, 48, divided by 2, 27 divided by 2. Oh, 27 doesn't divide by 2. Okay, now I'll do 3. Does 3 go into it? All right. And so on. So what's the biggest number you can see that would divide into both of those?
So 3x squared.
Close. 3x. This is an x to the third.
Oh, yeah. 3x cubed.
Yep. So 3x cubed. Does everybody see that? Because this one has x to the fifth, x to the third. So 3 of those x's can be taken out. Okay, so when we do that, so 3x to the third comes out. And actually, maybe I'll write it in a little bit of a different way here. Just to make sure everybody sees what I'm doing. So basically what I'm doing is I'm taking each of those terms and I'm dividing it by 3x to the third. And I mean, the book probably didn't show it this way, or the videos that you did, but sometimes people get lost and are like, where are they getting these numbers from? And then they're just reducing this, right? So if I'm looking at this, 48 divided by 3, that's 16. And then x to the fifth divided by x to the third is x squared. All right, and then I look at the next term. So negative 27 divided by 3 is negative 9. And then that x to the third and x to the third just divide out and doesn't leave anything else. Okay, but remember that 3x to the third, right, is part of our answer here. All right, so right now I have this. However, this can factor further. This is a difference of squares inside here. So you got to make sure that you're noticing, look closely and see, oh, can it factor further? All right. And so when we're doing that, so 3x to the third stays there. But now I'm going to write my parentheses here. So if I'm thinking, okay, what's the square root of this? Or what times what is 16x squared? Well, that would be 4x and 4x. And then what times what is 9? Or what's the square root of 9? That would be 3 and 3. And then to end up with no x term left there in the middle, that means that one of these must be plus and one of them must be minus. And so that would be my answer. That looks really weird. Let me rewrite it, make sure everybody can read it. So 4x plus 3 and 4x minus 3. But with that 3x to the third still out in front. And that is your answer. Okay, and again, you can check that by foiling. You'd want to foil these back together. You'd come back with this 16x squared and then distribute that 3x to the third back through, and then you'd come back with what you started with. Okay, okay, questions there on factoring? Okay, so whenever you have something like this, like whether it's a rational, meaning there's fractions in it, equation, or a fractional, either an equation or an expression. This one's an expression because it doesn't have an equal sign in it, right? We don't know what this is equal to. And I wanted to bring that up because I did see people just trying to take this and say it's equal to 0. Okay? You can't do that. This is not an equation. We don't know what it's equal to. It's not, that just changes the whole meaning of it if you do that. So it'd have to start off with some kind of an, equal sign in it. And I think there might be one later that's like that. They seem to show up sometimes. Yeah, so see this one right here? How this has an equal sign that starts out in it. Okay, so that's different. We treat these kind of differently from each other. Okay, so with this one, we need to get a common denominator. But the very first thing you want to do, so whenever you're dealing with anything with these fractions in it, is you want to factor first. Okay? You can't really do much with this until it's in factored form. So let's go ahead and we'll factor the denominators there. So I've got 7 over, well, what times what is -4? That adds to be -3. Notice my leading coefficient is just a 1, so that's why I can go straight to this. I don't have to take all those other steps that we did on that factoring problem up here, right? Where we had to do the first times the last, change it to a 4-term polynomial, and then do all of that. Since that leading coefficient's 1, I can go straight to this. So what multiplies to be -4 that adds to be -3?
-4 and -1.
Yeah, -4 and -1. So I've got x minus 4 times x minus 1. All right, and then minus 4 over, well, here, this one's a little bit different to factor. So this, you can see there's a greatest common factor of x. I've got to factor out first. And when I factor that out, that's just going to leave me with x minus 4.
Excuse me, don't we need to have a positive number underneath 7? One of those,
Oh yeah, did I not
those
make it out a
like-
positive? Yeah, this one should have been positive, sorry. I thought I made it positive, thank you. So x minus 4 times x plus 1, in order for those to make a -3 in the middle. Okay, so now we've got to figure out what your LCD is, because we need to get an LCD on this. Well, an LCD needs to be made up of everything, like every single part has to be accounted for. So do you see x minus 4 shows up in both of them, so that's good. That's going to be part of it. This x plus 1 needs to be part of it, but notice that this one is missing x plus 1. So I need to multiply that by x plus 1, all right, because it's missing it. And then this one has an x that this first one doesn't have. So that's also part of my LCD, but I need to multiply by x here. Okay. So now I've got the same things here, but whatever I do to the bottom, I had to do to the top. So that's why I put it in a different color here so you can see. So I needed to multiply the bottom by x in order to make my LCD. So I've got to multiply that x on the top as well. Here, let's see, I'm going to go over here further. Here I was missing the x plus 1, so I need to multiply by the x plus 1. Okay. And so my LCD is, I'm just going to write it down like this because we're going to combine this together now as one fraction. Remember with, whenever you're like adding fractions together or something, right, they have to have a common denominator. These are now common, so I can now combine those together, either add or subtract them. And this one is telling us to subtract. But on the bottom, so I'm going to have x times x minus 4 times x plus 1. And then on the top, I have 7x. And then be really careful with this negative. Sometimes people forget to do that. So I usually tell them to move that, like change this to add a negative. Put that negative on that 4 because you're distributing a -4 to both of those, not a +4. So just be really careful with the sign. So that's going to be -4x and then -4. Okay. Okay, so now let's combine our like terms there that we can. So 7x minus 4x is 3x minus 4. And then on the bottom, we've got x times x minus 4 times x plus 1. Okay, and that's all we can do. There's nothing more that can be simplified. If there was something that could simplify, we'd have to factor this top. And this top didn't factor. Like say it was like 3x minus 6 or something like that, right? And I could factor, a 3 out of both of those or something. Well, there's nothing that can factor there. So I am done. That is my answer. Okay, so when you're dealing with these where they don't have an equal sign in them to start off with, you can't kill off the denominators. The denominator is part of the answer. Just like over here, like if I was adding this together, that gives me, right, if like this would be 6/7. I can't just say, I can't get rid of the denominator and just say that's 6, Having 6 of something or 6/7 of something is a totally different thing. So just be really careful with that. Make sure that has the denominator still is part of the answer. Okay. Questions on that? Sometimes the ones with the fractions, and people are like, oh, I just haven't made fractions my friend. And, so try and just, work through a few problems like that. Usually something like this will show up on a final too. Okay. Well, this one looks really similar too from the last exam. You had something kind of like this. And yeah, and so, a lot of you did pretty good on it, but some of you forgot like the first step. And those of you that like remembered the first step usually did pretty good all the way through it. But the first step, like we got to think to ourselves, we're trying to solve for x, right? But right now, this x here is caught inside a square root. And so I can't really solve for it when it's stuck inside there. So I've got to think to myself, okay, well, how can I undo square rooting something? Well, I would square it, right? So I'm going to square this side of the equation and square this side of the equation. So when I do the left side, the square root and the square undo each other, and so I'm just left with 3x plus 15. However, on this side, right, I've got x minus 1 all squared, or that's also, I'm going to write it down as x minus 1 times x minus 1, because you're going to have to FOIL this before you can do anything else on it. Okay, you're not just distributing that power through, you've got to FOIL it. Okay, so this side stays the same, and then here I'll get x squared minus x minus another x, and then -1 times -1 is +1. So in the middle there, right, I got a -2x. And now I need to bring everything over to one side and get the other side equal to 0. So I'm going to choose to subtract that 3x over this way, and I'm going to subtract the 15 over this way. And so when I do that, this is just 0 on this side, which is what I was trying to do. And then the rest of this, I get an x squared minus 5x, and then 1 minus 15 gives me a -14. Okay. And then sometimes some people stopped at that point. And they were just like, oh, I don't, but you haven't solved anything yet. You haven't figured out what x is yet. So then at this point, you're going to factor this again, right? Because how do I solve something when it's an x squared? I got to factor it. So what multiplies to be -14 that adds to be -5? What times what is -14 that adds to be -5?
X minus 7, x plus 2.
Okay, so x minus 7, x plus 2. Okay, then what do I do with those at this point to solve for x?
Set each quantity equal to 0.
Yeah, so I'm going to have that x minus 7 equal to 0 and the x plus 2 equal to 0. All right, so here I get x equals 7, and here I get x equals -2. Okay, however, notice giving us kind of a hint up here to check, right? Check our solutions, make sure that they both work, because when we have square roots, we could have an extraneous solution. Remember, we can't get a real number answer if we're trying to take the square root of a negative number. Now, that doesn't mean that this is automatically not the right answer. It's if that whole thing inside, right, becomes a negative number once I put that in. That kind of gives that sometimes is a problem here. Okay, so let's just do our check over here. I'll do the check so you can see what I mean here. So I'm going to put x equals 7 in there. So I'll have the square root of 3 times 7 plus 15. Does that equal 7 minus 1? All right, so here I get 21 plus 15, which is going to give me square root of 36. All right, and square root of 36 is 6. So 6 equals 6, so that means that is a good, whoops, I don't want to square that. That's just my check saying, yes, that works out. So that means this is a good solution. Okay, but now I've got to check the other one because it could be that one or both or neither solution works. So we got to check the other one out now. Now let's put -2 in here and see what happens. So I've got the square root of 3 times -2 plus 15 equals -2 minus 1. Okay, so I get square root of -6 plus 15. Okay, and that's going to give us the square root of 9. But over here, remember, we've got -2 minus 1 is -3. All right, but this doesn't hold up true because square root of 9 is 3, which does not equal -3. So that means this one is an extraneous solution. So our only solution on this is x equals 7. So make sure you do the check. Like if it gives you in the instructions, like it says check, it doesn't mean that one of them doesn't, work out, but it means you better check it because it could be that way that maybe one or both of those solutions don't check out. Okay. Try and give you like little helps on the exam to remember like which ones you need to check.
I just have a quick question.
Yeah.
Will this continue till 12? I just have to pick up my preschooler.
Yep, it's going to continue till 12. I have it recording right now, and so I will have it uploaded too. So if you want to start, whenever you have to leave, just look at how much time we are into it, and then you can kind of gauge that and watch the rest of it later. That's fine.
Thank you so much. I appreciate it.
Of course. Okay. So let's go to this next one. So this next one, we are trying to solve a system of equations with 3 equations in 3 variables. And so when I'm doing this, the very first thing I look at when I am, trying to decide where I want to start on this, I guess, is I look at each of the variables and see if there is one of the variables that looks a little bit easier to get rid of than the others. And for me, in this case, it looks like the x's might be easiest to get rid of because do you see this? I like to number these as equation 1, equation 2, and equation 3. All right, so equation 1 and equation 3, if I add those together just how they are, the x's will automatically eliminate. Right? And so I don't see that happening in any of the other ones. And so that's why I would choose to look at that first. And remember, whatever one you eliminate first, whatever variable you eliminate first, you got to eliminate again. Okay, so let's get into it and show you what I mean. So I'm going to take equation 1 and equation 3, and I'm going to rewrite those out over here. So x plus 2y plus 5z equals -5, and then -x plus 3y minus 3z equals 19. And be really, really careful with your signs, especially when you're rewriting them down there. It's easy to mess these up just because of just not being careful with your signs. All right, so my x's eliminate, which is what I was trying to have happen there. And then when I add the rest of it together, I have 5y plus 2z equals 14. All right, and then I'm going to call this equation 4. Oops, what happened here? Okay, I'm going to call this equation 4. So I have, and then I'm going to go back to my original 3, and I need to get rid of an x again, either doing equation 1 and equation 2, or equation 2 and equation 3. Well, to me, it looks like it's probably going to be easiest to do 1 and 2. Because if I multiply that equation 1 by a positive 3, I'll have 3x here. 3x minus 3x will make that eliminate out. So I'm going to do equation 1 and equation 2 next. All right, so let me write these down again. Okay, and so like I said, I'm going to take that top equation and I'm going to multiply it by 3. Okay, so now I'm going to write it down underneath here so we can see what happens. So that's going to give me 3x, and then I've got to distribute it through everybody. So plus 6x plus 15x, oops, z, I mean. What did I do? Okay, let's get our variables right here. 3x plus 6y plus 15z equals negative 15. All right, and now I can combine these next parts together. I can see, all right, my x's eliminated. And remember, I've got to eliminate those same x's. If you don't do that, you're going to end up in a mess and you're going to be like, I don't know where to go from here. Okay, so write that down on your paper. If you've gotten lost on these types of problems before, it's probably because you didn't eliminate the same variable at the beginning of it. Okay, and then what's left? We've got 8y plus 13z equals negative 7. And then I'm going to call this equation 5. All right. Okay, so now I need to put equation 4 and equation 5 together, and I need to eliminate another variable. So I'm just going to write that over here. So 8y plus 13z equals negative 7. Okay. And so on this one, so there's my equation 4 and equation 5. It looks like it might be easiest, and it's probably about the same to eliminate y or z. I'm going to choose to eliminate the y's. And so to do that, a couple of different ways you could do it, but the easiest way to think about it is take whatever coefficient that is there on that 8, and let's make that negative, because that will give us a negative 40. And we're going to multiply that all through by negative 8. And this one we're going to multiply by a positive 5. Because remember, I need one of them negative, one of them positive in order for those to eliminate out. Okay, and so when I rewrite those distributed through, I'm going to have negative 40y minus 16z equals, let's see, what's 8 times 14 there? Let's see, 32. Negative 112. You want to check me, make sure. It's negative there. Okay, and then on the bottom one, 40y, and then plus 65z equals negative 35. Right, so on this one, my y's are now gone, which is what I was trying to do, right? And so now I'm going to combine those together. So 65 minus 16 gives me 49. Oops, let's see. This 49z equals, now I need to combine those together, right? So the 112 and the 35, they're both negative, so it's going to give me negative 147. And then the last thing I need to do is divide by 49. That is a 7. It's kind of weird there. And so what do we get there?
3.
Z equals 3, or it's going to be...
Oh, -3.
Yep, -3. Awesome. Okay, so now we finally got to the first one, right? But getting to the first one is the hardest for sure. And notice it says we want your answers written as an ordered triple, right? So I'm going to write it kind of up here as an ordered triple. So we'll do our X, our Y, and then our Z. So we found our Z, so that goes here. All right, so now I'm going to take this Z equals -3, and I can put it back into either equation 4 or equation 5, because see, if I put, it in place of Z, then I just have one variable left to solve for. So I'm going to choose to put it here, just because this guy looks kind of lonely over here, right? It'll be easiest to show you what I'm doing. So if I do that, I'm going to have 8y plus 13 times -3 equals -7. And now I'm just going to solve this for y. So 8y minus 39 equals -7. All right, and then let's add that 39 over. So I get 8y equals 32. -7 plus 39 is 32, and then divide by 8. So y equals 4. So 4 there in the middle needs to be that. Okay, and now I've got just one more here that I need to look at, right? So I'm going to take what I have for my X, my Z and my Y, and I'm going to figure out my X. Well, I'm going to choose to use this top equation just because X is already by itself. And so it will just be easier. I'm just trying to make my life easier. You could use any of the first 3 equations though, right? Those original equations. But if I use this one, I'm going to have X plus 2y, and y is 4. So I'll put 4 in place of y. And then plus 5z, so plus 5 times -3, and then equals -5. So let's solve this one. So x plus 8 minus 15 equals -5. X minus 7 equals -5. Let's add the 7 over. So x equals 2. And that will be my last one there. So 2, 4, -3 is my answer right there. Questions? Okay. Well, let's go to this next one here then, right? All right, so this one's saying if f of x equals 3x minus 4 and g of x is x squared plus 3x plus 5, find f of g of -4. So again, this is something that was in the very last chapter, right? And so, and when we're doing this, notice that let's see, let me kind of get rid of this so it's a little bit easier for me to do this. So we're taking whatever that -4 is and we're putting it into our g function first, and then whatever answer we come up with that, we put it into our f function. So I'm going to first write down what, we're going to find g of -4. So that means I'm looking at that g equation, and everywhere I see an x, I'm going to replace it with a -4. So I've got -4 all squared. Make sure you put it in parentheses because that whole thing, that -4 is our x, plus 3 times -4 plus 5. So that's going to give me 16 minus 12 plus 5, all right, which gives me 4 plus 5, which is 9. Okay, but I'm not done yet, Now I need to take that answer that for 9 and I need to put it into my f function, right? So now I'm trying to find what is f of 9. Well, my f function is this, 3x minus 4, so I'm going to have 3, and then in place of x, I'm going to put a 9 this time. 3 times 9 minus 4, so it's going to be 27 minus 4, which is going to give me 23. So that would be my answer. All right, so take that negative 4, put it into the g function because that's the one that's closest to what we're doing there. Then take that answer, put it into the f function. Okay, graphing these inequalities. So it's going to be easiest if, you have these in slope-intercept form. And it looks like on these are already in slope-intercept form, so that is nice. And then from there, you can graph them kind of easier. So remember when we're graphing them, and it's in y-intercept form, we're going to start with that y-intercept, okay? So -3, so that's here. So I plot that, whatever that y-intercept is first, and then I do my slope from there, which is 2 over 1. So up to right 1, up to right 1, right, up to right 1, and so on. And then I need to be careful. So remember, if I have a less than or a greater than symbol, you need to make sure you're using a dotted line, which is what I have on this one. So this one is going to be a dotted line. I'm sorry, these are not very straight. Pretty hard to do it on here, okay? And then I need to do the shading. So this is the part that people forget to do. Like they'll remember to do the dotted line and the solid lines, but they forget they've got to do the shading of it also, right? So this is saying y is everything less than this line. And so everything less than is below the line. So that would be this stuff here. Now, in the book or in the videos, they may have told you to put in some test points, like, picking like some kind of test point right here for it, which you can totally do, but you don't have to. If you can look at that and say, okay, if something's less than that line, that means it's going to be below the line, right? So if it's less than, it's below. And if it's greater than, it's above. Okay, and that goes with for less than or equal to or greater than or equal to, right, as well. Okay. All right, so now I'm going to do the other one in a different color. So let me get rid of that because it was kind of hard to read what was going on there. Okay, so I'm going to start here with +2 on my y-intercept, so that's here. And then from there, I'm going to go down 4, because I've got that -4 there, down 4, and then right 3. So 1, 2, 3, 4, over 3, 1, 2, 3 is here. And then I can see that my line needs to look something like this. And then on this one, it's again less than it, so I want the stuff that's below the line. And so this time, the stuff below the line is the stuff on this side. Okay, but then my answer is just where they overlap. So let's see, I'm going to change this maybe to purple or something. So the part that is my answer is just the stuff that's right here where they're overlapping. So make sure on the test that you like shade this, the part in really dark that you are meaning to, or only shade that part on the, on it if you want to make sure that I know, like erase the other stuff over here. If it's going to be hard for me to tell what you're saying the solution is, okay? Because this is the answer. That is your solution right there in the purple, okay? All right, story problems. Okay, there are going to be a few story problems on here. There's usually not very many on the test, maybe sometimes 2 or 3, but there are going to be definitely a few on here. Okay, and so this one says, a boat can travel 3 miles upstream against the current in the same amount of time it takes to travel 7 miles downstream with the current. If the speed of the current is 4 miles per hour, so I'm going to underline some of this, so 3 miles upstream, 7 miles downstream, and the current is 4 miles per hour. Okay, find the speed of the boat is what we're trying to find here in still water, and make sure you use your units on this. Okay, so on this one, and I know I gave a lot of feedback on a type of problem like this on exam, on the second exam, where some people were forgetting an important thing, and that is what the rate is. Now we know that we're going to be using this formula, distance equals rate times time, and most people remember that that's what you're using on it. But the rate isn't just this 4 miles per hour. Sometimes people just try and put 4 in for R, but that's not the case on this because we're on a river, right? And so it is, think about being on a river. If you're on a little boat in a river and you're going downstream, right? You don't even have to paddle at all and you'll be moving because that current is going to move you. But if you're paddling, it's like going to move you faster than what you're actually going. Kind of like, you know, how you, like if you're on one of those little people mover things at the airport or something, like you can stand to the side and you'll still move along, right? Or you can walk on it and you're actually moving faster than what you could if you were just walking on the ground. So it's kind of that same kind of thing with this. So the rate is made up of the boat speed plus or minus the speed of the current. Okay, and it has to be in that order. You have to have your boat speed first and then your current speed second. Because otherwise, if you had it the other way around, you might come up with a negative answer. And then you're like, what? How can I have like a speed of a boat is negative? Well, you can't, right? So that would be a very bad situation for you. So let's go ahead and set this up in a table. So we know stuff about downstream, we know stuff about upstream, and so we're going to be making some equations that deal with that. And then we need to know the distance, the rate, and the time. Okay. All right, so what do we know about the distance? Well, you can travel 3 miles upstream. So that 3 is going to go there for the upstream, and 7 miles downstream. So I got my distances written in. Okay, but how am I going to write the rate on this if I know the current is 4 miles an hour? And one other thing, and I didn't say this over here, but I want to make sure that it's really clear. You want to like assign your variables to this. So meaning I'm going to say, okay, B is my boat speed, and I'm going to call C my current speed. All right, it's always a good idea to you need to define those variables, what your meaning is what. Okay, so knowing that I've got, I'm calling them B and C, what would my rate be going downstream? I'm not looking for a number because we don't know the answer yet. But we know it's the boat speed, either plus or minus the current speed.
Is it B plus 7?
Yeah.
Yeah,
B plus 4, right? Because our current is 4. Yep. So B plus 4. And it's plus because as you're going downstream, think about it, like as you're going downstream, that current is pushing you 4 miles an hour faster than what you can actually paddle, right? And going upstream, it's slowing you down. Have you guys ever tried to paddle upstream? It sucks, right? I've been, on a canoe where I've had to paddle upstream and stuff. I was like, right? But it's slowing you down. So that would be where we'd have B minus 4. Whatever the boat speed is, it's going to slow you down 4 miles an hour from that. Okay. And then the time, all we know about the time is that it says in the same amount of time. So that means they're equal. The times are equal to each other. Okay. But this equation right here, we didn't solve in terms of time. And so we need to do that in order to do this next part. So if I'm trying to get t by itself, I'm dividing by the rate, right? Distance divided by rate is the time. And so what I'm going to write here is, okay, I know the downstream, my distance is 7, and my rate is b plus 4. So I'm going to write it as 7 over b plus 4. And then here, my distance over rate is 3 divided by b minus 4. And then I need to put these equal to each other because it says in the same amount of time. Okay. So I'm going to set it up as 7 over b plus 4 equals 3 over b minus 4. And now this is an equation, and so we're going to end up like getting rid of the denominators by multiplying by the LCD. So you end up here with doing 7 times b minus 4, and on this one, we're doing 3 times b plus 4. Whoops. And then I just need to distribute those through and solve it all the way. So I'm going to come up here just because I'm kind of running out of space. So I'm going to have 7b minus 28 equals 3b plus 12. And let's get our numbers on one side and our variable b on the other side. All right, so I'm left here with 4b equals 40. And then I just need to divide by 4. So b equals what? What is that going to be?
10.
10 what?
Miles.
Yep, miles per hour, right? Because we said, that it's our boat speed that we're trying to find. So that needs to be written in miles per hour because that's what we're dealing with, right? It gives us miles and it gives us hours. And so we know that's going to be in miles per hour. So our boat speed is 10 miles per hour. Okay. All right.
Did we need to use the variable c for anything on here?
Nope, because that one's the one given to us, right? So it gives us our c right here. So that's what I put in here, because this would really be b plus c, and this would be b minus c, but I just already filled in the 4 in place of that. So, yep. Okay, and then I'm just going to give you a little hint here. You are not going to be asked to rationalize that denominator, so I'm going to skip over that one, okay? Just a little hint. You don't have to know how to do that for the final. Okay, but let's go to this next one here. So this, again, is something from this last exam, or this last module, where you're going to be trying to solve exponential equations using this like basis formula. So we need to get these so the bases are the same. And right now we have a base of 4, and then this is 1 over 64. So one way that you can go about it to try and get those bases the same, if you're not quite sure how to do it, is you could, break this down. 8 times 8 is 64. 4 times 2 is 8. 4 times 2 is 8. And then 2 times 2 and 2 times 2. So I really get, so 64 is the same thing as 2 to the 6th power, right? Or I could also say, if I was writing this down, because if I started off differently, I might be able to see 64 is also 4 to the 3rd power. And it doesn't matter which one you use on this, as long as you're making those bases be the same. So this one already has a base of 4. And so it would be easiest just to use this 4 to the 3rd power, but I could change that 4 here to be 2 to the 2nd power, and then use this one and have it 2 to the 6th power over there. So I'm just trying to show you there's more than one way you can do that. Okay, but if we leave it as a base of 4, then I'd have 4 to the 3x plus 4 power, and then 1 over 64. Well, that's a fraction, right? So I really have like 1 over 4 to the 3rd power. Well, in order to get that so it's not a fraction anymore, I need to flip it upstairs, which is going to make it angry, right? It's positive downstairs. We've got to flip it upstairs, which is going to be 4 to the negative 3rd power, which is what I want to have here so that my bases are the same. So 4 to the negative 3 power. And now once those bases are the same, I just set those exponent parts equal to each other. So I put that equals that. All right, so I've got 3x plus 4 equals negative 3. Let's subtract the 4 over. So 3x equals negative 7, and then divide by 3. So x equals negative 7 thirds. Okay, and you would get that same answer if you chose to write this, as 2 to the 2nd power. Like it would look like this. It would be 2 to the 2nd power times 3x plus 4. Ugh. And then on the other side, we'd have 2 to the 6th power, right? And so you'd put like all of this equal to 6 that time. Sorry, a negative 6. Because we had to flip it upstairs. Okay, but either way, you're going to get the same thing. So I just want to make sure that's clear. Okay. All right, let's go to this next one. So it says solve using the quadratic formula. All right, so that means this is not going to factor, more likely than not. So that's why it's saying to write it this way. But in order to use the quadratic formula, I first need to get everything over to one side and put the other side equal to 0. So do you see, I need to subtract 1 over first. Let me write it over here. So I'm going to have 6x squared plus 2x minus 1 equals 0. All right, so I need to write it like that way first. So then I can figure out what my a, b, and c are. So a is 6. B is 2, and C is negative 1. And then you've got to have this quadratic formula memorized. I have it on there, right? And it says x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, and by all over, I mean that negative b and the square root, right, are all being divided by that 2a. And now I'm just plugging numbers in there, and then you can use your calculator to kind of to get, to help you simplify it from there. So when I put those numbers in, I get x equals negative 2 plus or minus square root of 2 squared minus 4 times a, which is 6, times c, which is negative 1, all divided by 2 times 6. All right, and then I just need to kind of simplify up things inside here. So negative 2 plus or minus the square root of 4, and then this is going to be negative times a negative, so this is going to give us a positive here, so plus 24 all over 12. Or negative 2 plus or minus the square root of 28 all over 12. And I'm going to actually write this when I'm dividing it by 12. It's really like each of these are kind of being divided by 12. You don't have to write it that way. If it comes out to be like where you have an imaginary number, if that was a negative inside there, you would need to split it up because imaginary numbers need to be, in that a plus bi form. And so you'd have to do that. So I just tell students, like, you might as well kind of put it in this, form and stuff. Now that square root of 28 isn't all the way simplified, right? So if I simplify the square root of 28, let's see, I'll go up here. All right, that is 4 times 7, and 4 breaks down to be 2 times 2. So 2 times 2 times 7, so it looks like that 2 gets to come out, all right, and the 7 stuck inside. So here, let's see, I'll write it down like this. So this would simplify to be 1/6 plus or minus 2 square root of 7 all over 12. And then that could simplify to be 1/6 also. So I get negative 1/6 plus or minus square root of 7 over 6. And like I said, if you wrote it in the end, on this one it doesn't matter. You could have negative 1 plus or minus square root of 7 all over 6. Like, I don't care like which way it's written. This way it's a little bit easier to be able to reduce each of those fractions. But if there's nothing to reduce, then writing it that other way is totally fine as well. Okay, but that would be your answer on that. Is there questions there? All right, we are getting here. I know we got like about 10 more minutes left. We might go a little bit over just because I had some technical issues and we didn't get started right away. I want to make sure we get through these. Okay, so find the vertex, axis of symmetry, and y-intercepts. And the other thing I'm going to say is sometimes they ask for x-intercepts, and so I want to find those on here as well. But I'm going to use one that's a little bit different than that one, just because if they do ask you to find the x-intercepts, they'll make it nice for it to factor. So they would give you something like f of x equals 3x squared plus 22x plus 7. Okay. And so when we, whoops, sorry, that's probably loud in your ear, I accidentally hit that. So to find the vertex, right, you need to know the vertex formula. And so that's over here as well. Remember, x equals negative b over 2a is that vertex formula. So I'm going to write it here. So vertex x equals negative b over 2a. Well, our b is 22, so I'm going to have negative 22 over 2 times, oops, wait a minute here. I guess it's going to give us a weird fraction here, but that's okay. Oftentimes they'll work out nicely, but this one is going to be not as nice, I guess. So 2 times 3, which is 6. And then we'd want to reduce those. It looks like 2 can go into both of those. So that would be negative 11 over 3. So that's what we would get here. And then we just need to find out what y is. I need to put negative 11 thirds in place here. All right. And I'm fine, like if you use your, I mean, I know a lot of your calculators, like you could put this whole thing in there. As long as you write it out like this and show me what you're putting into your calculator, I'm fine with you doing that. Okay, I'm going to put it into mine right now and see what we come up with here. Make sure you guys come up with the same thing that I'm coming up with. Like I said, usually they'll come out with nicer numbers than this, okay? Because that one, yeah, is like negative 100 over 3. And if you were going to try and, graph this on here, we need to change these so that they are not as a, fraction. We need to know what those are. And this is going to be off the charts here since I just kind of made one up here. Sorry about that. Make it up on the fly, and sometimes the numbers don't work out as nice. Okay, but so this is kind of like negative 33.3, and then 11 divided by 3, is about 3.7. All right, but like I said, these numbers would come out nicer. They'll probably be whole number answers, so you won't have to worry about that. Okay, so I'm just going to so over 3.7 down, I'm just going to come clear down here, right? And so that's going to be kind of where my vertex is. It's going to be a lot further down than that, but I just can't go any further down. Now my axis of symmetry always lines up with whatever my x coordinate is here, and I need to write it as an equation. So I write it as x equals -11/3. And that is this line that goes through. It's a vertical line that goes through here because parabolas are symmetric, right? They're these U-shaped, and there's always going to be like a line of symmetry that goes down the middle of them. So that's what this line is. It's telling us. Right now, our y-intercept is nice. Okay, some of you on the last exam, you were looking at this and you were making it much harder than you had to. When it is written in standard form, this is your y-intercept. So that is going to be 0, 7. Right? So over 0, up 7. Put it there. And then now we need to, I'm going to do my x-intercepts, and to do that we just need to factor this. So this will give us a little bit more practice with factoring something like this. Okay, so remember, like we did before, we'll take the 3 and the 7 and we'll multiply those together. So those multiply to be 21. So what multiplies to be 21? That adds to be 22. Well, it looks like that's going to be 21 times 1. All right, gives us positive 21. Add them together, we get a positive 22. And so we'll rewrite that as a 4-term polynomial like we did before. So 3x squared, and then plus 21x plus x, and then plus 7. And then my greatest common factor, I'm going to split these up, right? It's a 4-term polynomial, so we do factor by grouping. So 3x comes out of that, leaving x plus 7. And then here, be really careful with this. Sometimes people get lost on this going, what? But if there's no greatest common factor, there really is a 1, is what we can factor out of both of those. So it's really saying like plus 1 times x plus 7. So x plus 7 goes in one parenthesis, and then 3x plus 1 goes in the other parenthesis. And then to find my y-intercepts, I have to put them equal to 0 and solve it. So here x equals -7, and here x equals -1/3. Sorry, I'm trying to kind of go through it quick. Right, you'd set both of those equal to 0 and solve, like we've done before. So we'd have, let's see, right? Something, oh, wait a minute. I didn't go on the negative. Nobody said anything to me. That was supposed to be, the vertex was supposed to be over here. I was like looking at that going, wait a minute, what is happening? Okay, let's try this again. All right, that should have been over here. So over -3-ish, down 33-ish, right? And then remember that I got my axis of symmetry kind of coming through here. I'm sorry, this graph isn't very good, but like I said, numbers are going to come out so much nicer on the exam. And then I can see, okay, I've got -7, 2, 3, 4, 5, 6, 7, and then third is about here. Oh man, I have that in the wrong place, so it looks really funny. Should be like this. All right. And so then I have something that kind of looks like this. Wow, that's beautiful. Okay, Okay, but like I said, it'll give you a lot easier one. I should have chosen something easier there with some numbers that weren't so crazy. Would have been better to do. Okay, so, but make sure you know how to find the vertex, axis of symmetry, y-intercept, and the x-intercepts. And so our x-intercepts, when we write those down as ordered pairs, that's going to be -7, 0, and -1/3, 0. Right? So, because our x is this, but our y is 0, which is what these were right here. Okay, got just a few more here to go. Let's see, and actually on this one, we're not going to be doing this one anymore because it asks us to use matrices, but that was taken out. So since 2021, that's something that is no longer being tested on, so we don't need to do that one either. Okay, so we just have a couple more to do here. Okay, so with this one is an equation this time with the fractions. And so on that, this is where we get to kill off the denominators, and it feels so good when we get to do that. But first thing you've got to do, remember, whenever you're dealing with any kind of fractions like this, you've got to get everything factored. So do you see down here, this is a difference of squares. That factors to be x minus 6 times x plus 6. Okay, so it's no longer that anymore. It factors to be this. And so that means if I'm looking at my denominators here, right, I've got an x plus 6, x minus 6, and then this has both of them. So that means my LCD is x plus 6, x minus 6. And I need to multiply each part by it. Let's see, so I'm going to rewrite this down here because I don't have enough room over there. So I'm going to write this down. So 2 over x plus 6 minus 3 over x minus 6 equals 2x over x minus 6 times x plus 6. Okay. And so I said I'm going to multiply each part by my LCD. And by doing that, I'm going to be able to kill off my denominators. Okay. You don't have to work with your denominators on this. When there's an equal sign, you can kill them off, which makes it so much easier to deal with. Okay, so I'm just taking each of these and multiplying it by each different part. And then I can divide out the common factors. Do you see everything's connected here by multiplication? 2 times x plus 6 times x minus 6. So since that whole x plus 6 is on the top and on the bottom, I get to get rid of both of those. Okay, and then over here, my x minus 6 get to divide out. And on this one, all those get to divide out. So what am I left with? Well, here I'm left with 2 times x minus 6 minus 3 times x plus 6 equals 2x. And I know that some students go straight to this, and I'm totally fine with that. I just don't want to, miss steps here and like have people confused on how I'm getting those, like why it's x plus 6 here, why it's x minus 6 there. Okay, and then let's just distribute those through and solve it. So 2x minus 12 minus 3x minus 18 equals 2x. Let's combine our like terms together. So that's negative x minus 20. All right, if I'm putting this with that and these together, then equals 2x. Well, let's get our x's all on one side, so let's get our x over here. So now I get 20 equals 3x. Wait a minute, I did that wrong. That's 30, not 20. All right, I'm moving too fast and making little mistakes here. Don't like that. All right, negative 12 minus 18 is negative 30. Okay, so divide those now by 3, So x equals negative 10. And that will be your answer. Okay, and you should always check on these again to make sure that this number isn't going to make one of the bottom 0. So meaning if we came up with, say, x equals 6 as an answer, do you see that wouldn't work? Because if I put 6 in here, 6 minus 6 is 0, and I can't divide by 0. So that's what it means when it's saying check that your answer is in the domain, right? You just got to check the denominators there, that they aren't going to be 0. Okay. All right. So one more story problem here. A rocket is launched from a cliff, and then it gives us that's modeled by this equation right here. I'm going to rewrite it over here so I can see it better. Okay. And it says, so t is the time in seconds, h of t is the height at that given time. And it wants to know, when will the rocket hit the ground? Well, what's the height of the ground, right? The height of the ground is 0. All right, so we're going to be putting 0 in place of that h of t. So I'll have 0 equals negative 16t squared plus 96t plus 112. And then I need to solve it from here. So I could either try and factor it, or I could use the quadratic formula. And if it can factor, that's going to be the fastest way to go. But either way is fine. If you're like looking at that going, oh, that looks a little scary to factor, you could use the quadratic formula, but those are also big numbers to factor. Usually on these, like something's going to be able to come out of this. Like, so I would check to see, can negative 16 divide into all of those. So 112 divided by negative 16, yep, that's 7. And then 96 divided by 16 is going to give us 6. So negative 16 is a GCF. And once we take that out, the rest of it to factor is so easy, right? So if I factor out that negative 16, I'm left with t squared minus 6t, and then 112 divided by negative 16 is negative 7. All right, and then I can factor that further. So what times what is 7? That adds to be negative 6. Well, 7 and 1, and 7 needs to be negative, and 1 needs to be positive. And then I'm just going to set those equal to 0 and solve. This part, there's nothing to solve there, right? There's no t to solve for, so I don't need to set that part equal to 0. But the other ones, I get t equals 7 when I solve that one, and here t equals negative 1. But I am looking for the time, right? Could both of these be answers on this? Why or why not?
No, because time cannot be negative.
Yeah, time can't be negative. So we're just going to say, okay, let's get rid of this one. This was an extraneous solution for this given, story problem. We can't have negative time. All right. So our answer is just 7 seconds. And so that is what we will put. And again, make sure you notice it says use your proper units. You will lose points if you're not putting those units on your answers. Okay. All righty. We're getting there, kids. Okay, so another one with fractions again, right? And again, every time I've said, make sure you factor first, right? So you're going to factor first, and then this is division, so we'll divide second, all right? Factor first, divide second. Okay, so let's get everything factored. And I'm just going to write, well, let's see, maybe I'll write it this way first. So remember that when we're dividing, I mean, we're going to actually flip and change those to be a multiplication, all right? And so you can flip that first, but if you want, but you got to make sure that you're factoring things, because what I see people doing is they try and take like that, and they see that x squared there, and they try and divide it out with that x squared there. That doesn't work, right? You can only divide things out if they're connected by multiplication. And so that's why we have to factor everything on this. Okay, so I'm just going to write like a little note here that I'm flipping that second fraction. Okay, so on the top, when I factor this one, that's going to be what multiplies to be 18, that adds to be negative 11. Well, that's 9 and 2, and both of them need to be negative. And then on the bottom, looks like there's a greatest common factor on this to factor out. So 2x comes out, leaving x minus 9. And then over here, that 6x is going to be on the top. And then on the bottom, I need to factor this, which is a difference of squares, which factors to be x plus 2 times x minus 2. Right? So factor everything first here. Right? And then now we can divide things out. And that's what I mean by divide second, divide things out. So that divides out with that. Those x minus 9s divide out. And also this 6x and the 2x. So those x's divide out. And then 2 divides into 2 once and into 6 3 times. All right, so there's a lot of stuff that divides out here. So we've got 3 on the top and then x plus 2 on the bottom. And then that would be my answer. Okay, so once you divide or factor everything on there, from there, it's just so much easier. Okay. All right, and this last question on it is something again from Module 9, right? So notice like I can't remember how many problems there were so far, either 4 or 5. There's quite a few on here because you haven't been tested on it before. And so that's usually the case. There's usually going to be, close to 4 or 5 questions on that. So make sure you know this last stuff for Module 9. Or if you need more help with that, let me know. Okay, so we just want to graph this exponential function, and they just want us to make sure that we have at least 3 points. You can do more than that, all right? But so I like to pick numbers like -1, 0, and 1, but usually with exponential graphs, that's not going to be enough. So sometimes we'll have to do a 2 or maybe even a -2. All right, but let's put these 4 in and see what those look like and see if we need to make any more points. So if we put -1 in there, and I'm going to put it over here to the side just so I have more room. So 3 to the -1 power, all right, and then -4. Well, 3 to the -1 is 1/3. And 1/3 minus 4, well, you could either, like make those into common, factors, or you could, or you can, or you could put it into your calculator. Like, I'm not looking to see like your work on this kind of stuff with the fractions, but if you want to, you can, kind of show that out to the side. So this is going to be like -3 and 2/3, right? Because if we thought about this like this, we could think of this as 1/3 minus 3 and 3/3, right? So the 1/3 parts we have to subtract, and then the 3, so -3 and 2/3. All right, now let's put 0 in. So if I put 0 in, 3 to the 0 power minus 4, anything raised to the 0 power is 1. So 1 minus 4 is 3. All right, now let's do 1 in there. So 3 to the first power minus 4. So 3 minus 4 is negative 1. And we might have to go with some other ones that are a little bit higher up here. And then 2, 3 to the second power minus 4 is going to give us 9 minus 4, which is 5.
The y coordinate to 0 should be negative 3, right?
Let's see, wait a minute. Where did I make a mistake somewhere? Sorry.
Right above that, 1 minus 4.
Oh, 1 minus 4, yes, is negative 3. Thank you. Yes, that one should still be negative, not positive. That would give us a weird looking graph here. All right, and then make sure I did all of the other ones. Okay, so 3 to the second power is 9, minus 4 is 5. Okay, so let's plot these on here and see if there's anything else that we need to put in. So if I have over negative 1, down negative 3, and a little bit more, over 0, down 3, over 1, down 1, and over 2, up 5. Okay, so we can kind of see what's happening here. And this is telling us right here that it is getting really, really close. There's an asymptote here at this line, y equals negative 4, because it's getting really, really close to that negative 4. And so that means our graph can't ever pass through it. So it's going to get really, really close, and then it's just going to take off, right? And so it's going up pretty steep, and then this side is just getting closer and closer and closer to that line. So that's approximately what that's going to look like. So just make sure if you choose some points, do you see if I just chose like those 3 there, it might be hard to tell what the graph is looking like, but choosing one more there made it a little bit easier to see. Okay. All right, well, I am gonna stop there as far as stuff that I'm working through. So remember, go through, like keep reviewing over stuff on the study guide, things that you need to go through, and then do those practice finals, right? Give yourself about an hour and a half, like I said, because they're shorter, and that will at least help you to get into make sure that you are in the right time frame, because I know sometimes people on the test have been like, I've been running out of time, and and so that you gotta just do a little bit better time management. If you are getting stuck on a problem, skip it. Just skip it and go back to it later. Like, don't waste too much time on one question where you could, later on you're like, oh, this one was so fast and I could have got it done had I went through all the problems first and then came back to them. So don't spend too much time on one question. Get through all of them first and then go back if you need to on ones that you were stuck on. Okay, so go through those practice finals and then reach out to me if you have more questions and stuff too. I did send you on the last announcement, there are going to be some more study sessions, right, that you could go to at the STEM Center. They're in person, but if you're able to go to any of those, that would be a good thing. They might go through another like past final exam or something at those, or they might take questions. They might talk about like some, study tips and stuff like that. Each, kind of workshop or review session can be a little bit different, so you could definitely get a lot of good different information from each of those if you can attend more than one. Okay, any questions? Anything else that you have?
I was wondering how long the final is, like how many questions it'll be.
It's 25.
Okay.
Yep, it's 25 questions. So usually, it'll be, I would say for the most part, most people take about an hour and a half on it. They're working through it, so that usually gives most students, 20 to 30 minutes to kind of check back over some of their stuff. So, okay.
Do you have any more like Zoom hours this week or maybe next week?
So I mean, I have my you can come to my office hours either on Monday or Wednesday next week. I will definitely be available then. Send me a message if you want to come to those, so I know, because oftentimes that last week a lot of people don't tend to show up. So if you want to come, I'm more than happy to be there. Just send me a message letting me know you want to come. Okay?
Okay. I think I emailed you through Canvas.
Oh, okay. Perfect. Sounds good. Yeah. So on Mondays, I mean, from noon to 1, but I can meet other times too. Like I can meet in the evenings if that's easier for you. On Wednesday, I have evening hours anyway from 5:30 to 6:30. But next week you're going to be taking your final, and so that's the last day to take it. So like I said, like I'm fine. Like I can meet with you on, Monday evening or Tuesday evening, depending on what you need, or during the day. Okay, I'm pretty flexible.
Thank you.
Okay, you're welcome. Any other questions?
Do you have, I'm just struggling a lot with radical expressions. So is there anything you can like help me out, point out how to start them? Because it's very difficult for me to start those equations, especially when you have like.
Let me put in here. So I have a YouTube channel. Like it's not organized that well, just because like, I mean, there's a bunch of 10 like videos that I have on there, but they are not, like the numbering of like the section is off from this class because it wasn't using that book that you're using in this class now. But everything is on there, so you could kind of go look through there and let's see, let me try and pull that up so you can see what I mean. And then more than happy to help you with some other things as well, on it if you're like, oh, that, but a lot of students say, oh yeah, that really helped a lot. So let me show you. So here is, and I'll send the link to this in the chat. So here's like my YouTube channel. And so there are, somewhere like, so you can look at, these are just the Math 1010 videos. And so you can go into there and then over here, right, it kind of tells you all the different types of things. So it does give this numbering of it, but for you, it would be like, most of the time it's one higher. So instead of being like 2.3, that would have been 3.3 in your book or something like that for the most part. But some of them are a little bit different. So there's definitely stuff in here for, you said the radicals or the rationals, like with fractions or with the square roots and stuff?
With the square roots.
Okay. So with the square roots and stuff, like, so all of this stuff right here where it's the, module 6 on this. So 1.1, through 6.1 to 6.3. Oops. Let's see. I was going to try and play that one. I didn't mean for it to do that. Yeah, but you can look here and like grab some of those, and then you can just kind of, scroll through them and see like, if there's parts. So this one's talking about properties of exponents for a lot of it, but then if you need to get into the radicals, that's more into this one. And I do go through like some other story problems and stuff too for people, but I give a lot of good explanations and stuff in here to help you with all of those different radicals. And so you can kind of just
to figure out,
skim through there to see what stuff is the things that you need the most help with. Does that make sense?
Yeah, it does. I like it when it has more examples on the ones in the homework are kind of very brief.
Yeah. And so this one
this
definitely
actually helps actually having this.
Yeah. So let me send that, my channel, to you through the chat. So then you guys can have that. Or I think you can probably just search for my name. Those of you that are going to be watching this after, you can just search for Becky Connolly on YouTube, and you should be able to get into all of those, get into my channel there. Okay. But if you have other questions, like specific things that you have questions on, and if you're like, oh, I'm not going to be, I can't, meet, but I have a question on this, I can sometimes just make a little video or something for you too to help explain stuff. But this gives a lot of examples on it. So you'll have a lot of things to choose from here to watch. Okay.
I had a question about, is there anything that we maybe don't need to study as much on? I know there were a few things that weren't on our last exam that I struggled with and I studied really hard for, and then they weren't on the exam.
Can you think of some of the things? I can tell you if they usually show up or not.
One of them was use substitution.
That has never been on the final exam, so
okay.
I would not study that at all.
Good to know. Thank you.
Yeah, you're welcome. Good question. You don't know unless you ask, right? So you might as well ask. Any other questions you guys have?
I have a question about the rocket question because I did it on the review and it was asking for the maximum. Is that just finding like the vertex?
It is. Yep. If you're asked to find the maximum, that is the vertex.
Okay. And then for the extra credit reviews, it said to show our work, so I wrote down all of it, but I can't find it.
Sorry. Yeah, I should have spent. So remember, I just told you these were tests, right? These were final exams during the pandemic. So I'm sorry, all of the instructions and stuff on there were as if it was the final exam. And so I'm not looking, for you. I mean, it's going to be helpful for you to go back and, have your work and stuff shown, but you don't need to upload that anywhere. I'm going to go through, like, if you work on it and I can see that you've, worked through and tried every question, I am going to give you like all of the extra credit points on it. But if I look through it and it looks like, well, you've left a bunch blank, or like the answers just seemed silly and like you didn't, try on some of them, then you won't get the full points. So I don't need you to turn in the work or anything, but it is going to be helpful for you to have it to look back on once you see which ones you missed and go back and try and figure out, like the right way to do it. So good question.
Okay. Thank you.
Yep. You don't have to do the extra credit, of course. It's just extra. I highly recommend you at least try and go through one of those practice finals, because usually students that do those extra credit practice finals tend to do better on the final exam, but it is totally up to you. It's extra. It's not going to count against you, but yeah. And then there's also that course evaluation that you can get extra credit for too. So yeah, just a couple of possibilities there for you, but up to
sorry.
you. Yeah.
Go ahead.
Go ahead.
I just wanted to know I couldn't see it, but like the last day to turn in the extra credit.
It's going to be the 3rd of May. Okay. Yep. Very last day to turn in that stuff. Yeah. What's that?
Does that include like other assignments?
If they're still open,
okay,
then yes. The very last day to turn anything in that's still open is May 3rd.
Okay. And then I had another question, but I forgot. Oh, the module that wasn't included that you sent an announcement out to go over.
Mm-hmm.
Is that for sure going to be on the exam?
Wait a minute. Which one? Which module? Or do you mean
you sent an announcement out that it wasn't included in our online modules?
Oh yeah, no, it's not going to be on the final.
Okay.
Nope. Yep.
Thank you.
Yeah, you're welcome. Any other questions? These are great questions. I'm glad you're asking. All right. Well, reach out to me if you have more questions, and good luck to you. You guys can do this. And remember, whatever score you get on your final exam, if it's better than one of the exam scores that you already got, I will automatically replace it, right? So maybe you scored like a 65 or something on one of the other ones, and you get an 85 on the final. That 65 will automatically become an 85. I can't drop any exams in math, but I can replace those exam scores with what you get on the final. So keep that in mind too. Okay.
On the flip side, if you have previous exams are a higher grade, none of those will replace the final exam.
Oh,
correct?
no, it would only be to help you. That's a good question. I'm only doing it to help you. Yeah, just if you've, learned the stuff since, you took that first exam, I want to give you credit for that. But yes, I would never lower your grade like that, but that's a good question. All right. Okay, guys. Well, I hope you have a super duper day, and I will be available next week if you need extra help. Just reach out to me and let me know when would work for you, okay?